So this video is going to help you do the rational root theorem. The rational root theorem will help us find all possible rational roots of a polynomial. Doesn't mean there are going to be a rational root. So just for a quick example, in general, let's let f of x equal 2x cubed plus 3x squared minus 17x plus 12. If p over q, which is any type of fraction, is a root, then p has to be a factor of the constant, 12, or q is a factor of the leading coefficient, which in this case would be 2. So our first equation that Mr. Griffin's going to help us out with is f of x equals x to the 6th plus 4x to the 4th minus 41x squared plus 36.
Alright, so the first thing we're going to do is we're going to figure out what our p and our q is. If we look at our constant here at 36, this is going to be, factors of this is going to be our p. So we're going to have, obviously, plus or minus 1, plus or minus 2, plus or minus 3. This is not looking good for us. Plus or minus 6, plus or minus 9, plus or minus 12,
4.
I forgot plus or minus 4, plus or minus 18, plus or minus 36, and I also forgot plus or minus 4. Good news is our leading coefficient here is going to be a 1, so we're not going to have to play with fractions on this one. We're going to stick to whole numbers. Now, as far as where do you start, it doesn't really matter because at this rate, all these choices, you're going to do a lot of guess and check. Now, on the test, we're not going to let you use the calculator for problems like this, so you got to be good at guessing and checking. I'm just going to start off with 1. Why not? So what I want to do is I want to take my coefficients in front of all my variables here and put them down. Remember, if there's like x to the 5th is missing, so I'm going to put a 0. So I have 1 for x that's in front of x to the 6th. I don't have an x to the 5th. 4 x to the 4th. I don't have an x to the 3rd, so that'll be 0. So minus 41 for x squared. I don't have an x, and then I have a 36. So like I said before, I'm going to start off with, let's start with positive 1. So if you remember, we're going to do our synthetic division. You're going to bring the first term down, so I have 1. 1 times 1 is 1. And then we're going to add. 0 plus 1 is 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. 0 plus 5 is 5. 1 times 5 is 5. Negative 41 plus 5 is negative 36. 1 plus negative 36 is negative 36. I like the way this is headed. 0 plus negative 36 is negative 36. 1 plus negative 36 is negative 36. So I do indeed have a remainder of 0. So 1's going to work. So I'm going to scribble out here this plus 1. We tried that one and it works. Alright, so next one I'm going to do, while we're at 1, let's go ahead and try negative 1.
Mr. Griffin, why are we doing another one?
Because this right here can be broken down some more. And I don't think that I'm smart enough to have something x to the 5th in order to break that down to figure out the roots. And since I'm not allowed a calculator because the G squad is really, really mean, they're taking it away from me, we're going to have to keep going until it's a quadratic so I can break it down. So, let's do negative 1. Do negative 1 here. See if I can bring this out. Alright, so again, bring my first term down. Negative 1 times 1 is negative 1. 1 plus negative 1 is 0. Negative 1 times 0 is 0. 5 plus 0 is 5. Negative 1 times 5 is negative 5. These two added together are 0. Negative 1 times 0 is 0. Add negative 36 to 0, I get negative 36. Times these two together, I get positive 36. Hey, look at that. I get another remainder of 0. Now, sometimes if you don't get a remainder of 0, and hopefully I won't, but if you don't get a remainder of 0, then you need to just erase this and pick another number. But so far, my guessing is pretty good. Hooray for starting off with 1s. So I did all my 1s. If I look at my p's, I have all these numbers to choose from to try out. These are all relatively low. Let's go ahead and let's try 2. Might as well try 2. Alright, so if I try 2, back to synthetic division, bring this down. So I bring down my 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. 0 times 8, or 0 plus 18, excuse me, is 18. 2 times 18 is 36. Look at that, I'm lucky again. I get another remainder of 0. This is pure luck that I'm getting all these right the first time. Again, you're probably going to have to do some trial and error here, but so far it's working. So I'm going to scratch out my positive 2 here because I tried that and it did work. This is going to be remainder, constant, linear, quadratic, and a cubic function. So I need to do at least one more so I can get my quadratic in there. Since starting at the bottom and working up has worked really well for me, let's try negative 2. When I try negative 2, bring my first term down, and I have negative 2 times 1 is negative 2. Add these together, I get 0. Negative 2 times 0 is 0. Add these together, and I can already tell I'm going to like what I see here in a second. I get 9. Negative 2 times 9 is negative 18. And when I add this, I get 0. Now I have 4 roots right here in a quadratic. So let's come to the board over here and write down what we have so far. So if my root is 1, then I know my equation is going to be x minus 1. If my root is negative 1, it's going to be x plus 1. 2 is going to be x minus 2. Negative 2 is going to be x plus 2. And then my quadratic is going to be, and if you look at the remainder over here, this is my constant, my linear term, and my quadratic term, so it's going to be x squared plus 0x plus 9. I don't need to put 0x because 0 times x is 0, so I know it's going to be x squared plus 9. Now once I have this original equation here broken down, I'm going to basically find all the roots. So I'm going to set all of these equal to 0. So when I do my solution set, it's basically going to be my roots that I have over here. All right, if I can resolve these problems if I want to, or I can just write it down. 1, negative 1, 2, negative 2. And if you want to be smart and quick, you could just say plus or minus 1 or plus or minus 2. All right, and then this right here, I'm going to have to solve for this. So if I said x squared plus 9 equals 0, then I'm going to have x squared equals negative 9. So remember my imaginary numbers. This is going to be 3i and negative 3i. Or if we want to save time, we could say plus or minus 3i. And those are going to be my roots of our original equation.